If some of you can hear me and can see my video, just type in a yes or probably good morning in chat. Okay, I think we are live. So great. So yeah, I think I don't expect much audience today, considering that this is going to be the first live, and it's quite early in the morning. I did not announce it beforehand at many places, but yeah, those who are there, like we'll be going ahead and discussing all the major problems that were there in the given contest, right? The just contest that we had just about half an hour ago. So four problems are there. So yeah, I think we can get started. I'll talk about a little bit about purpose of channel till the time others are joining in. So yeah, basically I opened this channel to make sure that kind of short content that is going around, that we can have an actual in-depth content which lets us learn software development in real terms, right? So right now I'm starting with the contest discussion because that is something that almost anyone who is very serious will go ahead and attempt, right? So if you're attempting the contest and are stuck in some problems, it would be a good idea to check on these streams in some time, right? So I'll be generally going live in about half an hour to 1 hour after almost every contest of Leetcode at least, and even I'll try for some contest of Codeforces or maybe make videos around it, right? So yeah, that is the purpose. Slowly we might go into the depth of other software concepts, right? Which we slowly encounter as we move into the world of software development, right? So yeah, before like without wasting any further time, I would say let's go ahead and start with the today's contest, right? So yeah, this was today's lead code contest, and we had four problems. Uh, Slightly weird contest considering that like a lot of people solved the fourth problem just because it was a named problem, right? We'll talk about that as well. And yeah, third was I think less solved than fourth, so that is also interesting. But yeah, so if I talk about the first problem, it was relatively easy. We'll discuss that as well, and second and fourth then we'll go ahead and discuss, and then lastly I'll discuss the third problem. Okay, so let's go to the first problem quickly. So I'll go through the problem statement, talk about some brute force ideas, different ideas, right? If you also attempted it, I feel free to put it in the chat. I'll be taking up those example like questions as well, right? And yeah, let's go ahead. So basically, this problem said that let's say we are given an integer array nums, right? And it all only consists of positive integers, right? Although the question way it was framed, it said positive integers, but we did not really care about that. So what we need to do, we needed to find all the elements that have maximum frequency. So for example, if I look at this particular array, let's look at the maximum frequency. Maximum frequency is 2. So even 2 has that maximum frequency and even 1 has that maximum frequency. So you needed to find all the elements that have maximum frequency and give me the total frequency of those. So there are two 2's and two 1's. So answer is 4. If I talk about this, maximum frequency is 1 and all the 5 elements have that frequency 1. So answer is 5, right? Because the test cases were pretty bad, I'll take up one more example just to show it. So yeah, so for example, let's say our array contained 22333. Now, for this case, maximum frequency is 3 and there is only this 3 having that maximum frequency, right? So the answer is going to again be 3. Why? Because there are 3 total elements that are part of the maximum frequency. Whereas if I had 222333, then the answer would be 6 because now maximum frequency, even 2's are having maximum frequency and even 3's are having maximum frequency. So 3 plus 3, 6. So yeah, uh, those who are in the chat, were you guys able to solve this particular problem? Can I know from you all since it's live? How many were able to solve this first problem? Okay. Cool. I'll assume that, yeah. So I'll assume that like many people were able to do it, but still, yeah. So there are multiple ways in which we can solve the problem. The first and simple most way that I think is possible is to simply note down the count of each element, right? So let's have a map, an unordered map, representing count of each of the numbers. So for example, 2 has count 3, 3 has count 3, so on and so forth, right? So just note down the frequencies of each of the elements. Now, once we have the frequency, we can iterate and find the maximum frequency. So let's take another case. So like for example, there is two ones, there are three twos, and let's say there is only one three, and there are three fours. Let's say this is the example. So now we can iterate on the values and find out the maximum frequency. Then what I can do is, now I know the maximum frequency, let's say that is 3. I can count how many have that maximum frequency. So 2 and 4. So 2 have the maximum frequency 3. So the answer becomes 6. If we let's say have 5 also as 3 and 6 also as 3. So now 4 have maximum frequency 3. So answer will be 12. So just multiplying the maximum frequency and the number of elements in the maximum frequency, right? So if I talk about this particular case, then space complexity will be O of n, because we are having this frequency map, and time complexity will also be O of n. So it might seem like a trivial problem, but let's say if the interviewer tells you that you cannot use extra space, right? I don't want you to use extra space. Then anyone who can think of a way in which we can solve this particular problem without extra space. Okay. So if we talk about without extra space, we can in fact do it. We can do it with the help of the concept of sorting. So essentially, we are concerned about frequencies, right? And in general, if I talk about it, whenever you are dealing with frequency, there are two ways. Either you can use maps or sets, maps essentially, which are using extra space, or you can go for sorting. What happens when you sort an array? The elements which are same get together. So for example, if this scenario was there, right? So 1 occurs twice, 2 occurs thrice, 3 occurs once. So if this scenario is there, then in fact the array will become like this, right? So elements which are same come together. And now just to count the number of or the frequency of a particular element, we can go ahead and compare with the previous, right? So the previous is same, we increase the frequency by 1. If it is not the same, that means whatever the frequency we have calculated so far is for the previous element, and we can do the computation based on it. So I wrote with the help of this sorting algorithm. So I'll probably show across the code as well for that. So let me go ahead and go to my code. So let's go to my submissions. Take this up. Right. So if you look at it, what I did, I sorted the elements first. Step one, sort all the elements. Then what I did, I said that frequency right now is 1 because I've just taken the 0th element. Like number of elements having the maximum frequency is 0, and like basically maximum frequency means what is the maximum frequency as of now, and frequency count means how many have maximum frequency. So both are 0. So what I'll do, I'll iterate over the array. If ith element is same as the I minus 1th element. Why at 1? Because 0 I have already taken. So if the element is same as the previous, just do frequency plus plus. Otherwise, whatever the frequency we have calculated has been for the previous part. So if the frequency calculated so far is more than the maximum frequency, if it's more, then that means this is now the maximum frequency. So I update maximum frequency and do frequency count equal to 1 because we have found one element having this maximum frequency. Otherwise, if it is same frequency as the maximum frequency so far, so I'll do frequency count plus plus. So using this idea also, we can in fact go ahead and calculate the maximum frequency. We have to do this again once after the loop because the last segment would not have been calculated. So yeah, whichever of the two ways you used, map or sorting, both could fetch you the right results. Let me talk about the time complexity of this sorting approach. So since we are actually sorting, the time complexity of any sort is n log n, like the most common ones, quick sort, merge sort, whatever. It uses stim sort, the actual sort function of your C++. But yeah, n log n in terms of time. And we have not taken any extra space because we are just taking a few variables and we do away with the extra space that we had with the map. So both ideas were good. One involved taking extra space, one doesn't involve taking extra space. So that was the idea of the first problem. Any questions or doubt in this, do let me know. Otherwise, I'll move on to the second and fourth problem together. Anyone having any questions in the first problem? Okay, since it's live, I would really want everyone to interact a little bit. Like probably you can know if there is no issue, just type in can move ahead or something like that, right? So yeah, otherwise I could have just posted the videos. I actually wanted to try out having a live session like this. Okay. Okay, no issues. Great. Let's move on then. Arjun, thanks for replying. Cool. Let's look at the second problem now, right? So, second problem, which was actually same as the fourth problem as well. Part 1 and part 2. Okay. So, this problem says we are given first of all a string S, two other strings A and B, right? So, three strings S, A and B, and an integer K. So this entire thing is very complicated to understand, but I'll just summarize this, right? So basically what we want to do, we want to look at the occurrences of A in S. So where all does this A occur in S? So for example, if I look here, once here we have this my, second here I have this my. So two places where we have the A occurrence. Similarly, we want to look at the occurrences of B. Where all does it occur or where all does it start actually? So if I look at squirrel, there is one where squirrel occurs and there is another, right? So if I try to figure out the indices where my and squirrel occurs, so my occurs at index number 16 and index number 33. So 16 and 33. You can just do the calculation, but since they have already given, I'm not doing it here. If I talk about squirrel also, it occurs at here, which is what? Uh, yeah, index number 4. 4 they have given, 4 to 11. And index number 18. So you are interested in where all does A start, where all does B start. And now they say if for any particular A starting, if B starts in a range of K before it or range of K after it, then this A you have to count, right? So for example, here if I look at it, if I look at this my K is 15. So 16 is the starting of this my. So 16 minus 15, that is 1. If any squirrel starts between 1 to 16 plus 15, which is 31, almost the entire string, then you have to count plus plus for this my, for this index 16. Similarly for index 33, if I do minus 15 and plus 15 to this index, if any squirrel starts in this range, then you have to count this particular my as well. Okay. Uh, Yeah, so that is what the question says. So I'll probably take this, probably a simpler example, right? And try to explain for better case as well, right? So let's say we have simply ABCD ABCD. Okay, yeah. So let's say now my A is AB and my B is EF. So where all does this AB occur? It occurs here, it occurs here. Okay, so two places. Now, whatever the K is, let's say K is 3 or let's say 4. So wherever this starts, you need to look at 4 indices towards the left and 4 indices towards the right and see if any EF starts in that range. So 4 indices towards the left, there is nothing. 4 indices towards right, this range. EF doesn't start in it. So I will not count this AB. Whereas if I look at this AB, 4 indices to the right, so 1, 2, 3, 4, and 4 indices to the left, so 1, 2, 3, 4. Does an EF start in this range? Answer is yes. So I'll count this particular string, right? So basically the idea is you want to look at all the A's which occur as a substring in this. You want to look at K ranges towards left and right and find if any B string occurs in that range. Is the question clear to everyone? What it wants to say? If yes, just quickly type in a yes. I'll move on. Okay, perfect. So, simple idea that went ahead here was, let's look at the places where A starts. Why left and right both? Good question, Pratham. So let's look at the question again. So see this. It said j minus I absolute or modulo is less than equal to k. So wherever the j occurs, wherever the B string starts, and wherever the A string starts, the distance between them needs to be less than equal to k. But since it's mod or absolute, we need to consider both the possible ways. Does that make sense? Why it's in both sides and why it's absolute? Okay. Yeah. Thanks, Tarun, also for answering. Yeah. So let's look at where all does A start. Okay. So where all does A start? A start at index number 0. Then 1, 2, 3, 4. It starts at 4. Let's look at where all does B starts. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I just know where all does A start and where all does B start, my answer becomes very simple, like calculation becomes simple. Now what I need to do with this 0, I'll just do minus 4 and plus 4. K is 4, right? So that becomes minus 4 to 4. Is there any value in this second array between minus 4 to 4? Answer is no. So I'll not count this. If I look at this 4, minus 4 is 0, plus 4 is 8. Is there any value in 0 to 8 in this list? Answer is yes. So I'll count this. Does the idea make sense? So if I create a vector of all the indices where A starts and a vector of all the indices where B starts, then for every value in A, I just need to find a range and check if any number occurs in the second array in that range. Does this idea make sense? How we can go about it, doing it as a brute force? The two parts. So if I summarize the solution in two parts, part one is creating where all A starts and where all B starts, these two arrays, and part two is actually for every element in A start, find the range and check it in B start. So check in B for every A. Does this idea make sense? How we can split the solution into two parts? Then we'll see how to do each part in an efficient way, in a more organized way, right? And all that. Can I get a yes if these two parts make sense? Or if anything here doesn't make sense, let me know. Because this is the base of the solution. If you don't understand this, furthers will also be uh, here and there, right? Okay. So let's deal with the first part first. Like, let's try to easily find in S where all does A start, where all does B start. So if I look at the constraints of the problem, first problem, then you see that A and B are having length just up to 10, right? Very small length. And I keep on repeating this in a lot of different places as well. Whenever you are given a small constraint, generally there is a reason, right? It is not just randomly that a constraint is given very small, right? So since this constraint is very small, the first part becomes very easy. What we can do is we can go to each index of S, create a substring equal to length of A, create a substring equal to length of B, and check if they match with A or B or not, and just have a vector created. So let me go over and also show this, right? So I know this is not the best solution. There is a better solution of which, okay, sorry, I did back to contest. Instead of that, I need to do my submissions. Okay. So actually, I did not see that the two are same. So I went ahead and implemented second first, and then later I realized fourth was just an extension. So that is why I've written this. So basically, if you look at this part, what we are trying to do here, I'm going over every index of S I equal to 0, I less than S dot size. I'm trying to see if the substring that I make starting at I of length X, it is equal to A. So I'll push it in A indices. If it's equal to B, I'll push it in B indices. So with this help, I can actually get the first part achieved very quickly. I can get all the indices of A, all the indices of B. Does this idea make sense? What is the complexity of this? Complexity of this is S dot size into maximum of A and B size, right? So whichever is the maximum out of these. So that value is just essentially 10, because we are given that size of A and B would remain up to 10. So 10 into S dot size. That is how we can get this easily. Does this make sense? Right. In the next part of this, actually, A and B are having more value, right? So I'll talk more about it, how we can go about and handle that. But for this particular scenario, the second question, we could have simply got ahead with this and have our A indices and B indices. Okay. Okay, let me go ahead and talk about the second part now. So now that we have done the first part, so we have the indices of where A starts, we have the indices of B start. How to check that for given value of A in the range, does B lie or not? Anyone who solved it? What approach did you use in this particular scenario for the second part? Anyone who would like to chime in and suggest some ideas on how to calculate for each index of A minus K plus K, is there any element in B or not? That is what we need to do. Binary search. Very good. So since the arrays are sorted, what we could have done is for 0, I'll find this range -4 and 8. Okay, simply apply two loops. Very good. So yeah, brute force is that. Simply apply two loops. For every 0, calculate the range and iterate. But then it would be n square, right? Because there could be n values in A starts and n values in B starts. Yes or no? Does that make sense? In worst case, it can actually be n square. So the problem with that would have been that it would have TL lead, right? So if you applied two loops, very well, it's brute force, but it might have TL lead. So better way is to go for binary search. So what is the idea of binary search? We have this zero, we calculate this range, and then go ahead and find if there are any elements in this range or not. So if you would have done some problems like find just greater element or just smaller element in a sorted array using binary search, then that would have come helpful here. Another way where we don't even use binary search, like binary search is also n log n, which is more, we could have gone ahead with two pointers as well. So what is the idea of two pointers? So I look at this zero. What is the maximum range that this zero can make in the second one? What do you think? So if we have the k range, minus k and plus k, what is the maximum we can go with zero in the B? 0 plus k, which is 4. Yes or no? 4. So in a way, we need to check if 4 is there in, like, any number less than 4 is there or not in the B starts, right? If it is not there, then we can probably try to go to the next element. Does this idea make sense? Like using two pointers, basically. If our starting of A and starting of B, if they satisfy the condition of absolute difference being less than equal to k, then there is an answer and we can move A starts further. Otherwise, whichever is less, we can try to move it forward. So that is how I actually wrote my solution using two pointers, which is just O of n, which is like this. So I start at 0, 0 in both the A and B. So if the condition satisfy, if absolute difference of A indices I and B indices j, if that is less than equal to k, that means for this I have found a particular j where it is in the range. So I'll do answer dot pushback A indices I, because for A indices I have found an answer, and I'll do I plus plus, try to find for the next element. Otherwise, whichever is less, I'll try to move it forward. So if A indices I is less, then that this element doesn't have an answer and I'll move it ahead. If B indices J is less, that means all the elements that could have this J as the answer, they have been consumed. So I'll move this J forward. So using two pointers, I could in fact get the count and return that count. Does this idea make sense of using two pointers here? Those who have done binary search, it is just an extension of binary search by not every time searching, but just continuing from where your search left off. Okay, can I get a yes if this two pointers approach makes sense? So yeah, I would say this question was slightly tricky for second problem. Generally, second problem do not have such kind of algorithms being used. But yeah, a nice problem overall, I would say. Perfect, perfect. So yeah, if anyone doesn't have any doubt, if you have any doubt, please ask. Otherwise, I'll move on and discuss about the fourth problem, which was just optimizing this further, right? So if we talk about this complexity here, it is what? N into maximum of A comma B plus, this is again N because two pointers, so it is going to be N. So N into X plus N. So N into X essentially, right? Where X I am assuming is size of A and B. Okay. What about space complexity? We are having being stored this A indices and B indices. So space complexity is in fact going to be O of n, right? Can we do away with this space complexity? The answer for that is yes. We can actually do two pointers with I equal to 0, j equal to 0 in the same string, and then run some while loops to find the first occurrence, second occurrence, and do away with the space complexity. So this I would like everyone to try out, that can we do away with this extra space complexity by combining these two steps together, that is directly running two pointers and using that directly to find the substrings and compare. Okay, will everyone be able to try it out to optimize this further without extra space? Can I get a yes for that? It is possible. It will make the code a little messy, but we'll be doing away with extra space, right? So you might get asked such a thing in an interview to optimize the space further. Okay, cool. So let's try to move on to the fourth problem, which was an extension of this second problem. It said that your a dot length and b dot length now go up to 5 into 10 to the power 5. So now no longer you'll be able to go to every index of S and try to compare if A and B are there in that index or not, right? So it's an extension of our fourth problem. Okay. Any ideas? Anyone who solved it? How did you go about optimizing this step of n into x? Anyone who solved this particular problem? How did you go about optimizing this step? KMP Z function. Okay. KMP Z function. Any other ideas? KMP, I'll go for pattern matching. Right. Very good. So yeah, essentially, like this I didn't like about this problem as well, because uh, optimizing this is a very named standard problem, right? What is that named standard problem? Pattern matching. So what does pattern matching problem says? It actually says, given a string and a pattern, you have to find all the indices where that pattern exists, right? That is what the problem is. So actually, extension of optimizing the first part was just introducing this pattern matching algorithm. So there are multiple pattern matching algorithms, KMP, Z, Rabin-Karp, right? So you could have used any one of them. I'll give a brief about Rabin-Karp because it is an interesting one and used a lot in competitive programming. So that I'll probably do at the end of this lecture, depending on if the time is there or not. Or what I can do is I can make a separate video out of Rabin-Karp pattern matching algorithms, essentially KMP, Rabin-Karp, Z, right? So for now, you could have just optimized this particular problem by using any pattern matching algorithm out there, and that is what I did. So I introduced Rabin-Karp here. So let me go to my submissions. So I just copy pasted Rabin-Karp, literally copy pasted Rabin-Karp from uh, online, right? CP algorithms or any of such website, right? So yeah, this is Rabin-Karp. Just copy pasted it and just replaced getting my indices b indices from this Rabin-Karp algorithm. That's it. Rest exact code is same. So yeah, uh, like for this, if you knew what pattern matching is, you could have literally gone to any pattern matching algorithm, copy pasted that and used it here, right? So yeah, I'll make a separate video about pattern matching algorithms. Right now I think we can move on to the third problem, which was actually the, like I would say, the best problem out of the lot, right? Okay. Is that fine with everyone? Can we move on? Because right now, if I explain pattern matching, it would take 1.5 to 2 hours, right? So, not a good idea probably for this live. Okay. Let's talk about the third problem. Okay. So, third problem said you are given two integers, k and x, right? So, integer k, integer x. And what you need to do is you need to look at, you need to find actually a number num, right? So given, yeah, So given three integers k, x and num, right? So actually given two integers k and x, you need to find a number num. What you need to do, you need to find such a num such that if I write the binary representation of 1 to num, right? So let me take an example to explain it better. So let's say if k is 5 and x is, let's say, 2, right? So I need to find a num. So let's say if I try to find a num as 7, right? So I'll write binary representation of all the numbers till 7. So what are they? So 0, 1, 2, 3, then 4, 5, 6 and 7. Okay. So in binary representation of all the numbers from 1 to num, I need to count how many bits are 1, how many bits are 1 in all the places which are divisible by this x, right? So as an example, there are three places here. Is 1 divisible by 2? Answer is no. Is 2 divisible by 2? Answer is yes. Is 3 divisible by 2? Answer is no. So I just need to count the number of set bits in 2. Oh, okay, my bad. Whiteboard is not visible. Yeah, this is sorry. This is the problem with the yeah, video recording and live streaming. I had to switch between scenes, but okay, perfect. So I think now it should be visible. Let me know if it's visible now. Okay, I think it is visible. So let's go ahead and talk about it again once more. So let's say if k is 5, right? So I'll talk about what this k is, and let's say x is 2. For now, I'm giving this. Let's say I try to take num as 7. So what I did, I wrote the binary representation of all the numbers till 7. So 000 up to 111. Okay. Now, I need to look at all the set bits, all the bits that are 1 in all the places that are divisible by x. So if I talk about the places, it is being numbered from 1. This is the first place, this is the second place, this is the third place. So out of these places, which places are having value divisible by 2? Answer is only 2. So I just need to look at the second place. That's it. Just this place. And I need to count number of set bits in it. So there is 1, 2, 3, 4. 4 set bits. Right? Okay, so take any number num, note down all the numbers from 1 to num, their binary representation, look at all the places of bits that are divisible by this x, and count the number of set bits. If that count is, I need to find the maximum integer, I need to find the maximum integer where this count is less than or equal to this k. So basically, the first integer till which my count still remains less than equal to this value k, that if I go plus 1, then the count will become greater than k. Okay, so let's calculate the answer for this. So for 7 the count is less than equal to k, so it is fine. Let's add 8 also. Let's try to make it to 8. If I do 8, then the number will be 1000. Still the count is 4. Let's take 9, 1001. Count is still less than equal to k, which is 5. Let's take next number. What is the next number? So we have taken 7, 8, 9, 10. So 1010. Now when we take 10 also, the count becomes 5. Let's take 11, 1011. As soon as I take 11, the count should become 6. So my answer is 10. So you have to find the first number, right? The last number for which this given count is less than equal to your value k. Is the question clear to everyone? What we want to do? So given k x, you need to find that maximum num for which, if you write all the binary representation from 1 to num and look at all the bits that are divisible by x and count the number of set bits, that number is going to be less than equal to k. So that maximum number for which this number is less than equal to k. Okay, let's talk about brute force. What do we do when we do brute force? What we can do, we can simply try to find our num like this. So I'll try to start with 1. Currently my num is 1. While true, you count the answer for this num. If that count is still less than equal to k, you update num plus plus. This could be a simple brute force. Calculate the answer for 1. If it is less than equal to k, calculate for 2. If it is less than equal to k, calculate for 3. You keep on doing that till you get the first number where the count becomes greater than k, right? Yes or no? This could be the brute force. एक लूप चलाते रहते हैं. Let's keep on doing a loop. 1 2 3 4 5 6 7. Keep on calculating the count that we get till that number, right? And if that count is still less than equal to k, then we can try to find for the next number. Yes or no? Acha, tell me one thing. First time that I get count greater than k, can for further numbers, so let's say at 8, at num equal to 8, I get my count as 9, which is more than k. Can it ever happen that for a number greater than this 8, my count will be less than 9? What do you think? Can it ever happen that for bigger numbers, num equal to 9, num equal to 10, my count is less than this given count for 8? Answer is no, because if I take bade number like 9, 10, so on and so forth, if I take those numbers, then all the numbers from 1 to 8 are already there. So whatever their count is, that will already be there. We'll just be adding more numbers to it. Yes or no? Is this idea making sense? जो भी आंसर 8 का है, let's say that is 7. So answer for like the total count for numbers greater than 8, let's say 9, 10, so on and so forth, that is going to always and always be more because I'm adding more numbers. Yes or no? The idea समझ में आ रहा है क्या? So this proves monotonicity. So if you are aware of this term, common term monotonicity. So basically if you increase your num, the count also increases. Count of set bits that you wanted to count also increases. If you decrease your num, count also decreases. So if two variables are monotonically related, if one increases, the other increases, or one decreases, the other decreases, then there is a common approach of BS on answer, binary search on answer, that we can go for. How many of you are aware of this technique? Yes, no. Binary search on answer. Based on monotonicity. If you are not aware, then again, like for this particular technique, I'll try to make a small video about it, right? Okay. Some people are not aware. Cool. No worries. It's a simple idea. So I'll talk brief about it. So whenever your brute force goes like this, calculate the answer for 1, then 2, for 3, 4, till you get true, 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 true. Some condition is true. And suddenly when you reach a number and the condition becomes false, then either this or the previous is the answer. That is what is happening here, right? We are increasing num. We are checking if the number of set bits is less than k or more than k. So it is less than k, less than k, less than k, less than k, till we reach a value where it's more than k. So we need to find the last less than k. So whenever this true, 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 false, or false, 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 true occurs, this kind of a thing, then we can in fact do binary search. How we can do it? We'll land at a random mid. We'll check if it's true or false. If it's true, I'll try to search on the right side. If it's false, I'll try to search on the left side. So same idea of a general binary search you replicate in this kind of a scenario. Okay, cool. So yeah, anyways, even if you don't know the binary search on answer algorithm, still the problem had a lot of other layers that I'm going to talk about next, which are unrelated to it. So just stick around. Let's talk about those other layers. And then binary search was just a wrapper above it, right? Okay. So now the question comes, let's say you are given a num5 and you want to check if I write the binary representation from 1 to 5 and look at, I'll talk about high as well, right? I'll talk about high in the terms of when I talk about the code, right? So yeah. So as I said, if I look at 1 to 5, like if I'm given a number num, I need to check whether when I write the binary representation of 1 till this num and count the set bits of all the bits which are having divisible by x index, right? Is that count less than k or more than k? How do I go about calculating this? So let's say if I ask you, if you write binary representation of all the numbers from 1 to 5 and you want to look at all the even bits for now, right? So like position number 2, position number 4, position number 6, so on and so forth. And you want to count the number of ones in it. How do you go about doing it, right? So I'll talk about that with the help of a pattern. This is again a common pattern that we see a lot of times. So let's try to write binary representation from 1 to 10 for now, right? So I'll have 001, 010, 011, 100, right? Just for completeness, I'll add 000 also here. Okay. Then 101, 110, 111, so on and so forth, right? So if you look at the first bit, what happens? There is 1, then there is 0, then 1, then 0, then 1, then 0, right? If I include also the first 0, which is all zeros, then actually it is 0, 1, 0, 1, 0, 1, 0, 1, so on and so forth, right? So 1 repeats after every 2 steps. Yes or no? Can everyone see that? That is what it is, right? Odd, even, odd, even, odd, even. So 1 repeats after every 2 steps. Can everyone see that? If I write binary representation of all the numbers from 0 till a value num, then if I look at the last bit only, then it goes 0, 1, 0, 1, 0, 1, 0, 1. Yes or no? Let's talk about the second last bit. Now, what happens? 0, 0, 1, 1. Then 0, 0, 1, 1. Then again it would be 0, 0, 1, 1. So repetition of 0, 0, 1, 1. In first bit, the repetition was 0, 1. In the second bit, the repetition is 0, 0, 1, 1. Going by the pattern, the third bit, the repetition would be 0, 0, 0, 1, 1, 1. Fourth bit, 4 zeros, 4, 1. Does this pattern make sense? That how the bits repeat. This is again a very, very common pattern, right? Very common pattern that we encounter in bit manipulation. That if you look at any except position of bit, then if you start writing numbers from 0 till any number, then the bits would be like, first there would be x times 0, then x times 1, then again x times 0, then again x times 1. That is how the pattern repeats. Is this idea make sense? Does this idea make sense? What is the pattern like? Okay. Can I get a yes for this if this pattern is clear? Because this pattern formed the like basis of our solution, right? Okay. Okay. So now let's say I want to know how many set bits are there from 1 to 24 where third bit is 1. Okay. Third bit is 1. Tell me one thing. If third bit is 1, how many will have first, how many will have 0? How many initial numbers will have 0 in the third bit? How many will have 0 in the first bit? The third bit, sorry. How many initial numbers will have 0 in the third bit? So we are talking about the third bit. What is the frequency of its repetition? First three zeros, then three ones, then three zeros, then three ones. Yes or no? Not two, three, right? Again, look at it. So we are doing one indexing. So first bit repeats 1011 second bit repeats two zeros 21 2021 third bit repeats 3031, right? So if I'm talking about the third bit, it would be three numbers will have 0, then three numbers will have 1. So what will be the three numbers that will have 0? From 0 to 012. Then from 3 to, something went wrong actually. Third bit if I'm talking about, oh my bad, I made a mistake here. Right. So actually, if you look about, actually it became a little dirty here. I'll just make that correction. So if you talk about the first bit, then it repeats 010101, right? Second bit repeats 00110011. Third bit actually, if you see, repeats 4 times 0 and 4 times 1, not 3 times. Similarly, fourth bit will be 8 times 0, like it goes 2 to the power. 8 times zeros, 8 times 1. Does that make sense? So it's 2 to the power. For the first bit, 1011. Second bit, 2021. Third bit, 4 zeros. That is 2 to the power 3 minus 1. So 4 zeros, 4 ones. For fourth bit, 8. 8 zeros, 8 ones. Does this make sense? How it's slightly different? I did 1, 2, 3, 4, but it's actually 2 to the power. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. That is how many zeros and ones are there. Is this pattern clear? Sorry, I made a mistake with that pattern. Yes or no? For that, the explanation is very simple, right? Explanation is what? For two numbers, I'm going to have a 0 here. Then for next two, I'll have a 1 here. Then for next two, when I do plus 1, this will again change to 0. And it will keep on repeating like that, right? So this is the explanation basically, that it goes power of 2 essentially. Okay, cool. So basically, if I talk about third bit being 1, then for four numbers from 0 to 3, 0, 1, 2, 3, I'll have a 0 there. Then for next four numbers, 4, 5, 6, 7, I'll have a 1. Then for next four numbers, 8, 9, 10, 11, I'll have a 0. And so on. So 11 till 12, 13, 14, 15. So 12, 13, 14, 15, I'll have a 1 there. Which is also true. You can verify this. For the numbers from 0 to 3, from numbers from 0 to 3, we have 0, 0, 0, 0. 0, 1, 2, 3. 4, 5, 6, 7, we have 1. Then 8, when you go 8, 9, 10, 11, you'll have 0, right? So yeah, this is the idea. So basically we get a repetition of this much size, 8 size, which is 2 to the power the number of bit. This is the repeated segment of half zeros, half 1. Then size 8, half 0, half 1, right? So for any bit x, if I try to generalize for any bit x, there are buckets of 2 to the power x, out of which half are zeros, first half are 0, and second half are all 1. Is this idea making sense? This pattern? Because this would help in the final solutioning. कि for any bit number x, 2 to the power x की repetitions होती हैं buckets की. In that repetition, half of them are 0, half of them are 1. Yes or no? Okay. If this idea is clear, तो एक बार एक एग्जांपल के लिए निकाल के देखते हैं, राइट? तो मैंने जो बोला था ये वाला एग्जांपल, इसी को ले लेते हैं. 1 to 24 में थर्ड बिट कितनी 1 है, राइट? सो लेट्स कैलकुलेट दिस. ठीक है, तो I'll do the calculation. So 1 to 24 में how many third bit are 1? So let's go ahead, do it here. In 1 to 24, how many third bits are having value 1? So as I said, what is the bucket size? 8, right? 8 की buckets को अगर हम देखें, so out of which 4 are having 0, 4 are having 1. So till 24, let's take 0 to 24, how many buckets will be found of size 8? 3 buckets, 0 से 7, 8 to 15, 16 to 24, or actually 23, and last would be leaving out 24. Yes or no? 8 की ऐसी buckets होंगी. Can everyone see that? 0 से 7, 8 से 15, 16 से 23, and last remaining 24. Yes or no? अब इन 8 में से 4 of them will have 1. इन 8 में से भी 4 of them will have 1. इन 8 में से भी 4 of them will have 1. तो यानी 24 में से 12 नंबर्स में 1 होगा. If I talk about the last 24, since it's less than half, इसमें नहीं होगा, right? It will have 0. If this would have been 24 से लेके 28, then 24, 25, 26, 27, these 4 will have 0, but last one, which is 28, is going to have a set bit. So answer would have become 13. 29 होता तो आंसर would have become 14. ये आइडिया समझ में आ रहा है क्या? कि पहले how many buckets are complete वो निकाल लो. For all of them, half of the numbers are going to have set bit. Then the incomplete bucket, you find out how many numbers are more than half of that bucket size, और उनको भी आंसर में ऐड करना होगा. Does this idea make sense? कि कैसे बकेट कैलकुलेशन हो रही है. ठीक है, एक बार नहीं समझ में आया तो कोड देखते हैं. I'll explain the code once more, right, with the help of code. So you guys try to understand if it makes sense. And उसके बाद नहीं आता है तो feel free to ask questions, right? So I'll go to the submission. Okay, let me first go through the check function, right? So उसके बाद बाइनरी सर्च पे आते हैं. Let's first go about the check function. So what is check function? I want to know how many numbers from 1 to this value mid are having s x digit set and need to check if that count is smaller than or greater than k. So k को भूल जाओ अभी के लिए. I just need to count how many numbers from 1 to this mid have this and its related divisible things. Like for example, if x is 2, then second bit, fourth bit, sixth bit, eighth bit, so on and so forth. All these bits. Okay, change screen. Shit. Yeah. So I was talking about this check function, right? I've changed the screen. Just check it out now. So this check function has three parameters: mid, x, and k. Okay. I'll talk about this x again. Like from अभी के लिए इसको देखते हैं, calculate result को. I think this is a better function to look at as of now. है ना? So if you talk about this calculate result, what it does, it tries to find from this 1 to this value k. If I take all the numbers from 1 up to this value k, how many have this xth bit set? ऐसे कितने हैं जिनकी ये xth bit set है? तो मैंने क्या किया, पहले मैंने कंप्लीट बकेट्स निकाली. कंप्लीट बकेट्स कैसे निकाली? k डिवाइडेड बाय 2 टू द पावर x. रिमेंबर, x में क्या होता है, 2 टू द पावर x के बकेट्स होते हैं. 3 के लिए 2 टू द पावर 3, 8 के बकेट्स थे. 4 के लिए 16 के बकेट्स होंगे, राइट? सो कंप्लीट बकेट्स निकाली मैंने k बाय 2 टू द पावर x करके. अब ये सारी कंप्लीट बकेट्स में इसका हाफ जो है, half of them would be having 1. So answer 1 मैंने डाल दिया, half of it 2 to the power x minus 1, half of it into the complete buckets. यहां तक समझ में आया क्या? For complete buckets how did I do calculation? पहले complete buckets निकाली, उनका आंसर निकाला. Then the incomplete bucket I need to know उसमें कितने एलिमेंट्स हैं और हाफ से बड़े कितने. So I did modulo so that I know the remaining elements which are there in incomplete bucket, and I did remainder, which is this modulo essentially, minus half of them. कि हाफ में तो जीरो होंगे, तो उन हाफ को निकाल दो, उसके बाद कितने बचते हैं. If this remainder would have been less than half, the answer would be negative, so that is why I've taken maximum with 0. So ये calculate result समझ में आ रहा है क्या? Power function is standard, वो I think everyone would know, but this has the main idea that for for any particular bit I would find the complete buckets, calculate the answer for complete buckets, find the remainder for the incomplete bucket, और incomplete bucket में I'll do minus half of them because उनके में 0 होगा, remaining will have 1. So and then take maximum with 0 because this can become negative also, which we don't want. So this calculation is for given a number, if I write 1 to num, all the binary representation, कितनों में xth bit 1 होता है. Does this make sense? ऊपर power function है, तो that also I'm including. If this part of code makes sense, how it is happening. Yes or no? Okay. If this is clear, then rest of the solution was not that difficult. So what we did, we wrote a binary search on answer as we generally do. We specify an LNR while L less than equal to R, standard binary search, find the mid, check if mid has number of set bits, that is the count, less than or equal to k or not. If it is less than k, then we put it in answer and try to find a better answer on the right side. Otherwise, find on the left side. So very standard binary search that if you land at any mid, if the answer for that is true, you store it in the answer and try to find a better answer on the defined side. If the answer is false there, then you try to go to the other side. So standard binary search. Then in check, what I'm doing, I've initialized an answer as 0. I'm going through all the bits that are multiple of this x. So x, then x plus x, 2x, then 3x, 4x, all the multiples till log 2 mid plus 1, which is the number of bits in this element, because उससे ऊपर जाने का कोई फायदा नहीं है, all will be 0, and just summing up the result for each of those bits, and lastly checking if that total count is less than equal to k or not. So this has binary search on answer. This has the logic for going through each bit which are divisible by this x and summing up its answer, and this finally has your actual calculate result. Does this idea make sense how we are going about it? Okay, if I talk about time complexity, this binary search would be log of r minus l, which is 10 to the power 15 ka log, and then for each of the bits again it's log, and for each of the calculate also it's log, so log cube in a way, right? How brute force will give TLE? brute force में क्या करते हैं? brute force में दो तीन चीजें होती हैं. ये तुम फॉर लूप चलाते एल से आर तक एंड हर के लिए चेक करते, राइट? सो बिकॉज इट वुड हैव बीन ओ ऑफ एन एंड आर एक्चुअली तुम्हारा 10 to the power 15 भी आंसर हो सकता है, सो दैट ब्रूट फोर्स वुड हैव TLE'd, राइट? बिकॉज इनिशियली ओनली द लूप वुड हैव बीन ह्यूज. चेक वगैरह में दिक्कत नहीं है, चेक और कैलकुलेट ये तो ब्रूट फोर्स में भी ऐसे रहते. दिस लूप वुड हैव बीन अ प्रॉब्लम. ओके, वाइल log टू मिड दिस वन, तो मैं ये बोल रहा हूँ अगर यहाँ पे नंबर 10 to the power 4 है, इफ दिस नंबर इज 10 to the power 4, then the number of bits maximum that we need to go up to is the number of bits in 10 to the power 4. So that is why log 2 mid plus 1. Log 2 mid will be double, right? 3 point something something. So 3 point something means 4 bits तक हो सकता है. So that is why plus 1. ये समझ में आ रहा है क्या? We can directly do n and 1, n and 2 to the power k. कहाँ पर? n and 2 to the power k. n तो है ही नहीं मेरे पास कहीं, राइट? Where do you want to do n and 2 to the power k? Okay. One interesting thing that we did here is we passed in this function mid plus 1. Why did we pass mid plus 1? Because if you think about it, हमने 0 include नहीं किया है. तो for example, if we are calculating for 14, we want to know 1 से 14 तक, तो हमारी bucket में 0 count नहीं होगा. So it's better to count for 15 instead of 14 because उस 0 को include करना है bucket में. तो इसलिए यहाँ mid plus 1 पास हुआ है. So that is the only sort of a hack here, but yeah. ओके, कैलकुलेट रिजल्ट की जगह kth बिट इज सेट और नॉट. एक्चुअली दिक्कत क्या है, 1 से लेके k तक सबको देखना है, राइट? प्रथम सिर्फ kth को नहीं देखना है. ये वाला फंक्शन क्या कर रहा है, 1 से लेके k तक सबके बाइनरी रिप्रेजेंटेशन करूं एंड उनमें एक्सेट बिट कितने सेट हैं वो निकालूं, राइट? तो वो ये काउंट रिटर्न कर रहा है. सो दैट इज वाई वी कांट डू डायरेक्टली व्हाट यू आर सेइंग, बिकॉज नहीं नहीं, बिट तो हमने फिक्स कर दिए, एक्सेप्ट बिट की बात कर रहे हैं. 1 से लेके k तक सारे नंबर्स की एक्सेप्ट बिट को, उसमें से कितने 1 है वो काउंट कर रहे हैं यहाँ पे. ये समझ में आ रहा है क्या? जैसे फॉर एग्जाम्पल इस k इज 10, सो एक तरह से यहाँ पे अगर तुम ब्रूट फोर्स में करते हैं तो कैसे लिखते हैं, फॉर i इक्वल टू 1 to 10 और फॉर i इक्वल टू 1 to k, चेक इफ फॉर ईच ऑफ द i 2 to the power x से एंड लेके इफ इट इज 0 और 1, राइट? सो उस तरह से ब्रूट फोर्स लिखा जाता. बट यहाँ पे हम O1 में वी वांट टू कैलकुलेट, या O log n में वी वांट टू कैलकुलेट कि 1 से लेके k तक सारे नंबर्स में से कितनी क्या ये वाला पर्टिकुलर बिट 1 है या नहीं है. ये समझ में आ रहा है क्या? तो व्हाट यू आर सेइंग वर्सेस व्हाट दिस इज डूइंग, थोड़ा सा डिफरेंस है दोनों में. यू आर सेइंग कि k में वो 1 है कि नहीं है, आई एम सेइंग 1 से लेके k तक में कितनों में 1 है. ये समझ में आ रहा है क्या? ओके. ठीक है, एक बार ये देख लेना, लाइक डू चेक द सॉल्यूशंस आउट एंड ट्राई टू फिगर आउट, अगर और कोई अप्रोचेस दिमाग में आती हैं, फील फ्री टू डिस्कस देम इन द चैट ऑफ दिस लाइव। आई ट्राई टू आंसर दैट, राइट? कुछ कोड भी हों जो तुम्हारे डिबग करने वाले हैं, जस्ट पेस्ट देम इन द कमेंट्स। आई विल बी हैप्पी टू रिप्लाई टू देम, राइट, विद व्हाट इज रॉन्ग व्हाट इज राइट, ठीक है? सो क्या, ठीक है, आई थिंक वी हैव डिस्कस्ड ऑल दी 4 प्रॉब्लम्स, सो आई विल स्टॉप द स्ट्रीम नाउ। हाँ, सो 1 से k का लूप चला सकते हैं प्रथम, व्हाट यू आर सेइंग इज राइट, बट दैट वुड देन बी O ऑफ k। यहाँ मैं log ऑफ k में करना चाह रहा हूँ, एंड इसी के लिए मैंने ये पूरा लॉजिक बताया था कि बकेट्स में डिवाइड कर रहे हैं और हर बकेट के लिए आंसर निकाल रहे हैं। रिमेंबर दिस? तो यही, ये तरीका ही इसलिए था बिकॉज वी कैन, हाँ, टेली हो जाएगा, एग्जैक्टली exactly. 1 से k वाला टेली हो जाएगा। ओके, cool. So yeah, any other approaches, any other things, feel free to discuss it in the chat, right? We'll try to keep doing this for most of the contests, right? Yeah, and उसके अलावा भी मेरे वीडियोस हैं, पिछले कॉन्टेस्ट के मैंने वीडियोस डाले थे, तो डू चेक देम आउट। बाई वीकली के मैं वीडियोस ही डालूंगा बिकॉज बाई वीकली गेट्स लेट इन द सैटरडे, सो आई पोस्ट वीडियोस ऑफ देम ओवर द वीक। वीकली के आई ट्राई टू हैव लाइव डिस्कशंस लाइक दिस, राइट? तो या, कुछ भी डाउट्स हो, क्वेश्चंस हो, पुट इट इन द चैट। See you guys in the next videos. ठीक है, bye bye. Do subscribe to the channel. Do like the video if you enjoyed the solutions. ठीक है, okay, bye bye, and happy Makar Sankranti. We are entering a new year tomorrow. So yeah.